Hello friends, in today's question, a long horizontal rod has a bead which can slide along its length and is initially placed at a distance L from end A of the rod. The rod is set in angular motion about A with a constant angular velocity acceleration alpha. If the coefficient of friction between the rod and the bead is mu and gravity is neglected, then the time after which the bead starts slipping is. So we have given a horizontal rod. Let us draw the horizontal rod. This is point A, and bead is placed at a distance L. Suppose this is the bead. It is placed distance L from the end A, and the rod is set with the angular motion about A. So let us suppose it is with the angular velocity omega, okay, and angular acceleration is alpha. So we are supposed to find out the time after which the bead starts to slip. So in this condition, let us redraw the diagram with all the relative forces. So this is our point A. It is rotating in this direction, and let us suppose this is the axis, and we have bead here. Therefore, now it will try to slip away from this, and this distance is given as L. So it is going to have two accelerations. One will be centripetal acceleration AC, and another one will be tangential acceleration AT. And it will try to move along the direction such that it moves away from this, you can say, this point, and because of that there will be a frictional force Fr which will be acting along the axis of this rod, and because of this there will be a normal which will be acting in this direction. So this will be normal, and we are going to have tangential acceleration also in this direction. So this is our bead. Okay. So we can say that as the rod is in angular motion, so because of that the bead will move along a circular path, So bead will be trying to move something like this along a circular path. Therefore, we can say that angular acceleration is already given as alpha. Therefore, the linear acceleration of bead, which is given A, will be equal to alpha multiplied by length, that is L. And we can also say the centripetal force that will be acting on this bead, the centripetal force Fc will be equal to mv square divided by L. where v is the linear velocity. V is given as omega L, or here you can see V is linear velocity. So if we substitute the value of V omega L in this equation, we get Fc is equal to m omega square L square divided by L. L goes with this part, so we are left with m omega square L. So this is the centripetal acceleration. Now the slipping is going to start if the centripetal acceleration is equal to the maximum value of the friction. So here we can say when the centripetal force on the beam become equal to maximum friction, which we can call also the limiting friction, the bead will slide, or we can say that Fc is equal to the frictional force Fr max, and the value of Fr max will be equal to mu into n, okay, where n is the normal, and that normal will be provided by the tangential acceleration. Okay. Normal n will be provided by the tangential acceleration AT. Therefore, the force Ft will be equal to m into A, or we can say we already found out the value of A, that is alpha into L. So we can say from here that Ft is equal to m alpha into L. So this is the tangential force. So therefore the normal will be equal to m alpha L. So this is the value of the normal. Okay, so normal n will be provided by the tangential acceleration, or we can say tangential force Ft. Okay. Now we are going to use the value of normal n and find out our maximum value of the friction Fr max. We can say that our Fr max is equal to mu m alpha into L, and we already know that Fc is equal to Fr max, but Fc is equal to Fr max. From here we can say Fc is given as m omega square L is equal to mu m alpha L. So here m and m goes, L and L goes, so we get omega is equal to mu into alpha. Now we can use the equation of the motion, you can say using equation omega is equal to omega naught plus alpha t, where omega naught is 0, that is initial angular velocity, and final we know that is mu alpha. We substitute it here, we get this as mu alpha is equal to alpha t. This is omega square is equal to alpha, or we can say omega is equal to mu alpha square root. So from here we can say time t is equal to alpha upon alpha. So this gives us t will be equal to square root of mu upon alpha. So this completes the question. Okay. So this is the time when beads start to slip. This is the time after which bead starts to slip. So this completes the question. Thank you.